I'm Anil Kumar, and in this four-part series, we will review all the concepts of derivatives which we have learned in calculus. Now, this video is good for high school students and the university students, first year university students. We'll actually analyze this particular function, which is f of x equals to x to the power of 1 over 3 times x plus 3 to the power of 2 over 3. Now, first question. What do you think? Is it a polynomial? So what do you think? Is it a polynomial? What type of function is it? So my question is it a polynomial? Well, the answer is obvious. It is not. Is it a rational function? Is it a rational function? No, it is not. Rational function is a quotient of two polynomials, and if you have exponents which are not natural numbers, then they are not polynomials, correct? So the exponents here are actually radicals, right? So basically this equation involves radicals. You could say it is a radical function, right? That's kind of very important to understand. Sometimes students do refer this equation as a polynomial or maybe rational functions, right? But it is not, since the exponents are rational, right? Now, we'll consider characteristics in this particular video. In part 2, we will find the first derivative and thereby find increasing, decreasing intervals, maximum and minimum for the function. In part 3, we'll analyze the second derivative of the function, and then we'll find point of inflection. And then in part 4, we'll summarize and sketch the graph of this particular function, right? Now, let's consider the domain of the function. What is the domain of this function? As you can see, there are no restrictions. So we can say x belongs to real numbers. That is the domain of the function. The other important characteristics for this function will be end behavior, right? So let's write down what is end behavior. Now, when I say end behavior, it really means if x approaches negative infinity, what happens to the y value? And if x approaches positive infinity, what happens to y value, right? So in that case, what happens to y? And if x approaches positive infinity, what happens to y? That is end behavior. So if I take a very large negative value for x, even if I take minus 1000, then this value is going to be negative and that part is always positive. So we are getting a negative large value. So this will be negative infinity, and x approaches positive infinity. Both will be positive. So when you multiply both positive large numbers, you get positive infinity, right? So when we are sketching this function, the end behavior is kind of very important to understand. It reflects how the curve of the graph moves. So when I'm saying end behavior, x approaches negative infinity, y approaches negative infinity, it means something like this, that when x is large, that means approaching this side, y is going negative. And when I say x is approaching positive large infinity, y is approaching, that means that the graph will be going like this. So that is the end behavior which we are talking about, right? I hope this part is very clear. Okay. Now what else? Let's find the y-intercept for the function. So y-intercept is the point where the curve of the graph crosses the x-axis. So we can say what is f of 0. So if I substitute 0 here, I get 0. So y-intercept is 0. So that is your y-intercept. So graph is continuous. We know that. Since the domain is all real numbers and there are no restrictions. Okay. So, and the graph goes from quadrant 3 to quadrant 1. It has to cross the x-axis. Now that becomes the y-intercept where it crosses the y-axis. Now let's also figure out what are the x-intercepts. So what are the x-intercepts for this graph? X-intercepts are the point where f of x is 0, right? So that is the place where f of x is 0. Now the function is x to the power of 1 over 3 and x plus 3 to the power of 2 over 3. Now that is possible if the first part is 0, that is x equals to 0, or if x plus 3 equals to 0. Now that gives you the value x equals to minus 3. So we have two x-intercepts here. So the two x-intercepts are at 0 itself, where we have the y-intercept also, and one is at minus 3. So these are the two x-intercepts for us. See, as we develop all these things, we kind of get an idea about our graph, right? So now let us see the interval where the function is positive. Now interval where f of x is positive means it is greater than 0, right? So when is this function positive? And similarly, we will analyze the interval when this function f of x is negative. That means less than 0. That means it is positive, and this means negative, right? So we have to find the domain of this function where this function is positive. So, you can always pause the video, answer these questions, and then move on and check what we are doing, right? As you can see, there are two factors here. If you analyze these factors, let me rewrite these factors once again here, right? So we'll write f of x equals to x to the power of 1 over 3 times x plus 3 to the power of 2 over 3, right? Now let's try to analyze them a bit. Now this is square term here, right? Now that means always positive. Is that okay? Now this is 1 over 3. So if x is greater than 0, then this is positive. But if x is less than 0, then this is negative. Do you see that? So that dictates the positive and negative part of the graph, correct? So from here we get our answer. So we say that interval when the function is positive, greater than 0, is definitely when x is greater than 0, and it is negative if x is less than 0, right? So straight we get from the equation. So what I'm trying to say here is that, just drawing a line here, this really means that in this part, our graph is negative, right? So this part, graph is negative, this part, the graph is positive. That's what it means, correct? So we have got this interval also. Now with this kind of an information, can you approximately sketch the graph? This is very important to understand. Now one little thing is, when you've done so many functions in this course of calculus, learning about derivatives, you know that these are the kind of functions which have something very special, right? So these are the functions where you'll find a cusp, right? So there is a possibility of having a cusp. This is the place where the first derivative will be undefined. So remember that part. This is one. And second, we can find point of inflection also, right? So we can also find point of inflection, which we are going to get when we do part 3, where we are going to analyze the second derivative, where the concavity changes. Right? So once we do first and second derivatives, we'll exactly know the behavior of this graph and we'll be in a good position to sketch it. But from this information which you have, can you sketch the graph? That's a good question. Think about it. Now, let me tell you, we can fairly well sketch this graph. How? See, from the end behavior, we know that as x approaches minus infinity, y approaches minus infinity, we have a 0 there. So if we have a 0, we have to see whether it crosses at this point or not. So that is kind of critical to understand. So we'll do that analysis. Now the analysis here is, at x equals to minus 3, will the graph of f of x cross x-axis? That is the question which you need to answer. What do you think? Now since we know it is negative, we say the answer is no. It has to return back from here, right? Since on In this quadrant, it is negative. Do you see that? And therefore, we have fairly good idea that this function, whose graph is kind of going like this, will actually 3 on the x-axis, but it will not cross since it has to be negative. So it has to turn back. So it turns back, and this is the point where we'll have a cusp. We expect at least, okay? So it's just a thought. Now it has to return because there is another 0 here. So if it returns, it has to return, right? It has to return this point. So now it is positive after this point. So when it returns, it crosses. Do you see that? It crosses since it becomes positive. And thereafter, it doesn't have to return since there are no x-axis. So we expect it to go to infinity. You see that? So that is the graph which we expect. So what I'm writing here is the expected graph. Now, in the coming videos, part 2, 3, and 4, we'll get some values and we'll confirm whether that was a good assumption or not. Now, as a student, think about it. Were you in a position to sketch this graph from these basic characteristics? If you were, you are an excellent student. Now, let's move on to part 2, part 3, and part 4 to understand all other aspects of differential calculus with the help of just one function. I'm Anil Kumar, and I hope you are enjoying this journey with me. You can always share and subscribe my videos, and feel free to post questions and your suggestions. Thank you and all the best. Let's do part 2 now. Thank you.